I'm Jacob Dodson. I'm from the Air Force Research Laboratory Munitions Directorate. So today I'm going to talk about the need for speed microsecond structural health monitoring. And what we're going to talk about is the need to make rapid decisions with these really high rate weapon systems. And so this is actually kind of a natural evolution of my dissertation work where I looked at structural dynamics under my PhD and the need for implementation on weapon systems as we talk about these hypersonic weapons as we move in the future. So we'll kind of start at the basics. What is structural health monitoring? Now, I'll get into the details in a minute, but the goal is to be able to monitor and to maintain functionality of any system, so our application is a weapon system, under really harsh environments. So as we go in hypersonic regimes, we have extreme thermal environments, extreme mechanical environments, and we engage in our targets, possibly penetrating multiple layers before we actually get to our engagement. We need to be able to monitor and to ensure that our weapon system is going to do what it needs to do when it gets to the target. Because if it doesn't, if it starts to have degradation, we want a plan B. So how do we do that is we kind of have a system and we have a network of sensors applied to that system that feed us some information that really describe the dynamics or the vibrations or the thermal environment, and we're looking for a change in the system. So if nothing changes and engages the target as is desired, that's fantastic. But in these hypersonic flights, in these hypersonic terminal engagements, there's a lot of unknowns. If we see a change, especially an unexpected change, what we like to do is first we'd like to detect that change. We'd like to locate, figure out where on the structure, what's actually happening. We want to quantify the severity of that change, and that's going to lead to our decisions. So as we engage in these high speed, high rate dynamics, the question is, we have a couple questions. First, how long do I need to monitor the system before I can detect one of these changes, and how fast do I need to be able to detect and react? So that really leads to a very challenging problem because we're talking about microseconds and milliseconds. As we go through the atmosphere and as we head towards our target, we need to figure out a couple things. The first is, just to give some perspective, in 1 millisecond, 1,000th of a second, we transverse over 6 feet, 5.6 feet. And so if we want to make decisions or want to get updates on our system, let's say every 10 feet or so, we're looking at less than 2 milliseconds for that decision making. So that's going all through the algorithms, the sensor, the monitoring of our structure, the implementation, only to be able to get the decision on whether we're going to continue on with plan A or we want to go to some sort of plan B. So we need microsecond measurements for these millisecond detections. So the big question is how do we do that? It's a very, very tough problem. And so this is a basic research area that I've been kind of engaged in leading for the last couple of years. We're very fortunate to be able to have funding from the Air Force Office of Scientific Research, or AFOSR. And so we've been trying to establish this collaborations to tackling this microsecond structural health monitoring research area. So the Munitions Directorate, we're looking at using experimental apparatus coupled with computational models, and specifically feeding that experimental data into the models to try to detect what those changes are. So we're looking at types of changes we can evaluate. We're looking at how fast we can evaluate and how fast we can detect those changes. And this is certainly, it has to be a team effort. There are so many aspects to this problem.